In fact, the US is not worried about us surpassing them in economic scale. It's the technological discourse that defines great power competition. To maintain their position as the world's dominant power, they will naturally decouple from us in terms of technology. Recently, the news that ASML, under pressure from the US, will stop providing follow-up services such as licensing and maintenance to Chinese manufacturers has caught everyone's attention. In fact, this isn't the first time we've heard such news. As a foundational and leading industry for the next technological revolution, semiconductors are at the core of the modern industrial system, making them a focal point in the international political and economic competition of the digital age. In the past few years, the US has implemented policies like the Integrated Circuit Support Act and accelerations to contain China's rise, the small yard, high fence strategy, Washington Consensus for de-risking, and creating parallel supply chains. So, what is the situation of our semiconductor industry under the US blockade? Let's first talk about the characteristics of the integrated circuit industry. The integrated circuit industry is characterized by being knowledge-intensive, capital-intensive, having a long supply chain, and being widely applicable. The supply chain includes upstream elements like EDA software, IP licensing, materials, and equipment, midstream processes such as design, manufacturing, packaging, and testing, and downstream with a variety of system manufacturers. From the perspective of technical difficulty and profit distribution, design, manufacturing, and testing are the core processes of the supply chain. A chip production line requires about 2,000 to 5,000 processes, which are further divided into steps like photolithography, etching, diffusion, thin film flattening, ion implantation, and measurement. Each step must meet extremely stringent physical characteristics and cleanliness requirements. Otherwise, it can lead to contamination, breakage, and warping of the wafers, resulting in a decline in the yield of bare chips. Yield reflects the proportion of sellable chips in a wafer, directly impacting the manufacturing cost of the chips. For cutting-edge logic chips, a 1% improvement in yield at a wafer fab can mean an increase of $150 million in net profit each year. So, you can imagine the complexity of the processes in this industry and the vastness of the supply chain. For example, the key equipment for chip production, ASML's photolithography machine, is made up of 100,000 components. There are about 5,000 suppliers, with 80% coming from Europe, 14% from North America, and 6% from Asia. For EUV high-end machines, only 15% of the components are manufactured in-house, while 85% come from other manufacturers. ASML's strength lies in its ability to control the entire supply chain of photolithography machines and integrate thousands of components. These characteristics determine that it is inevitably a global industry chain. In the past, under the backdrop of globalization and the technological context of industrial upgrading and transfer, integrated circuits have formed the current industrial landscape. The US, Japan, and Europe control the upstream of the supply chain, capturing the highest added value, especially in terms of design software and equipment, where the US is absolutely in the lead. Among the top 10 design companies, only one is from Taiwan, MediaTek, while the rest are all American companies. Japan holds an absolute leading position in the materials sector, while China, South Korea, and Taiwan have competitive advantages in manufacturing and testing. Among the top 10 testing and packaging companies, 3 are from mainland China and 6 are from Taiwan. In 2023, the sales scale of China's integrated circuit market reached 1,127.69 billion yuan, making it the largest market in the world. Although our export volume continues to rise, we still face a trade deficit in this market. Since 2013, China's integrated circuit imports have exceeded crude oil, making it the top imported commodity for 10 consecutive years. According to research reports, semiconductor manufacturers in mainland China increased their production capacity by 12% in 2023, reaching 7.6 million wafers per month. It is expected that chip manufacturers in mainland China will start operating 18 projects in 2024, with production capacity increasing by 13% year-on-year, reaching 8.6 million wafers per month. According to the American Semiconductor Industry Association, China is projected to become the third largest semiconductor producer in the world, following the US and South Korea in 2024. However, due to export controls on advanced equipment from the US and others, most of our production capacity is concentrated in mature processes. That is, for 28 nanometers and more mature processes, it is expected that by 2027, the capacity share of mature processes in mainland China could reach 39%. Overall, we have made significant improvements in manufacturing processes, packaging technology, key equipment, and materials. In the fields of design, manufacturing, testing equipment, and materials, a number of representative companies have emerged. Public data shows that in 2022, during the bidding process for several domestic chip foundries, the proportion of semiconductor equipment produced in China reached 38%, which is more than 4 times the 7.5% recorded in 2019. Currently, in the area of 28 nanometers and above, our domestic semiconductor equipment manufacturers have basically... The influence of the industry chain is extremely limited. Therefore, we must firmly go out, trading oranges for apples, and exchanging market for technology. At the same time, we need to look for new breakthroughs and pay attention to technological changes. For instance, in today's market where bravery is key, improving processes has become increasingly difficult, highlighting the importance of packaging technology. Currently, glass substrates represent the forefront of advanced IC substrates and advanced packaging. Glass substrates can withstand higher temperatures and have excellent dimensional stability, thermal conductivity, and electrical performance. Their high-temperature resistance also provides flexibility for chip architects, enabling better power transmission solutions while achieving the high-speed signal transmission required for low power consumption. Although the technology for glass substrates is still in its early stages, forecasts suggest that the global market size will grow from $23 million this year to an astonishing $42 billion by 2034. This has also led to fierce competition among Apple, Samsung, and LG. This is a tough battle and one we cannot afford to lose. Integrated circuits are a strategic industry with a long investment cycle, high risks, and high difficulty set. It is also a national security industry with strong government guidance. Whether it is the United States, Japan, or South Korea, they are all led by the government without exception. We have the advantage of concentrating our efforts on major tasks and having strong organization. Secondly, in the face of such a complex supply chain and the vast amount of knowledge required, no country can rely solely on its own research and development for all technologies. Any industry in a period of rapid development faces the issue of talent shortages. The US's current monopoly position in the global chip industry is also the result of decades of technological research and institutional design, and it has gone through its own challenges with a lack of domestic talent. The United States has always had close cooperation with R&D institutions in Europe, Japan, South Korea, and Taiwan. Science and technology is people-oriented. In addition to cultivating talents ourselves, we must also find ways to create good talent policies and attract international talents. Ren Zhengfei once said that only by attaching importance to basic education in the long term can we achieve success. Only by placing long-term emphasis on basic education can we achieve industrial revitalization and create a fertile ground for talent. Universities are the best platforms for innovation. We need to be tolerant of knowledge and pursue research that may seem meaningless. We should encourage young scholars to boldly reach for the sky, pushing to the forefront of international advancements, while also digging deep into the roots. This way, basic education and fundamental research can become the driving force behind innovation.